Maxar, we turn big ideas into successful missions. Missions that address change on Earth and power exploration into our solar system and beyond. As a partner to innovative businesses and more than 50 governments, we've been building advanced technology since humans first began exploring space, and since we first started looking at Earth from above. Maxar space infrastructure capabilities harness the promise of space for programs like in-space robotics to explore distant surfaces, power and propulsion systems that will push us farther into the galaxy, and communications satellites that provide connectivity across the globe. As a leader in Earth intelligence, Maxar offers situational awareness to protect national security and empower soldiers on the ground, satellite imagery products sourced from our industry-leading constellation, and location analytics that use machine learning and analyst expertise to monitor and detect change. From the images in the navigation app on your phone to the satellites that connects that phone to the internet, Maxar solutions connect Earth and space to make information accessible and insights actionable, all for a better world.
Hello, everyone. Welcome to our session, Eyes in the Sky. We're going to be joined by Maxar Technologies in talking about using space-based intelligence to support your missions. My name is Manny. I'm with Amazon Web Services, and I look after the space and satellite solutions for Asia Pacific. When you're monitoring your assets, information and tools delivered with speed and precision can be the difference between making a decision and making the right decision. With the world's most advanced constellation, Maxar's Earth observation satellites support missions for customers in defense, intelligence, mapping and maritime sovereignty, homeland security, and many others. From broad area surveillance to precise object detection, government organizations partner with Maxar for trusted hardware, data, and insight needed to be more predictive in decision-making and more productive in daily operations. Our agenda today is split into two sections. To begin with, I'm joined by Rosalyn Carey, Solution Architect at Maxar Technologies. And Rosalyn's going to give us a little bit of an overview on Earth-based Earth intelligence, space-based Earth intelligence, I beg your pardon. Rosalyn, over to you.
Thank you very much, Manny. Good day, and thank you to Manny for that kind introduction and for APSCC for inviting Maxar to share today. I'm very excited to be here and covering this session, as Manny said, on space-based Earth intelligence. Maxar would like to share some insights on the work that we do around the globe with governments, both international defense agencies, civil government agencies, and the US government. We are living in a time where organizations need insight rapidly and reliably in order to make important decisions. Maxar supports these organizations in decision-making processes in a variety of ways. During my time today, I'll provide just a brief introduction of Maxar, an overview of the value that we bring to our international partners and customers, and then I'll finish off with some real-world examples of support we have provided currently and in the past. To begin, Maxar is a space technology and intelligence company with a history that dates back to the beginning of the American space exploration. Over the years, industry leaders in space manufacturing, satellite imagery, and geospatial analytics have come together to make Maxar the company that it is today. Whether or not you have heard of it, it is likely that you have interacted with our imagery or our derived mapping products. We have a daily collection of over 3.8 million square kilometers of new high-resolution imagery that underpins the value of Earth intelligence capabilities and is constantly feeding into a rich archive of over 125 petabytes of data that contains millions of square kilometers of imagery from our current and retired satellites. All of this that creates a digital time machine that allows you to analyze change dating back up to 20 years in very high resolution. This rich history of Maxar also extends to the customers that we support. To name a few, we support the NRO, NGA, DIA, and the DOA within the US government and extensive international governments throughout the globe. And we have supported these customers for many, many years. All these customers rely on Maxar for reliable current imagery to help them make decisions in rapidly changing global environments. Within the US government alone, there are over 400,000 analysts, warfighters, and first responders that utilize our data, and we are grateful and honored to be a part of these important and life-saving missions. Maxar provides Earth intelligence that goes beyond world-class high-resolution imagery. We also provide data-derived data layers, machine learning, and rich domain knowledge. This enables our customers to map, detect, and even predict change across the globe. Currently, we operate the most sophisticated Earth imaging constellation. We collect visible and multispectral SWIR infrared imagery that provide information beyond just what the human eye can see. And as we look towards the future, our next generation of satellites, Worldview Legion, will usher in a new era in Earth intelligence. With the addition of Worldview Legion, Maxar will offer the most available capacity over high interest areas from sunup to sundown. With these 6 high-performing satellites, both on polar and mid-inclination orbits, we will dramatically expand our capacity over high-interest areas and multiply our revisit times. But our high revisit rate is just one of the many ways Maxar brings value to our global partners. In the next slides, I'll walk through 4 other ways that Maxar imagery is unique and valuable. First, as I've mentioned, is our high resolution imagery. As you can see in these images, the detail and therefore the intelligence that can be gleaned from our imagery as you progress from 1 meter to 70 meter to Maxar 30 centimeter imaging capabilities is dramatic. Next is our accuracy. When mapping or planning missions, every meter of accuracy counts. Any variances or missteps can have drastic consequences, and our imagery is some of the most accurate in the world. And as you can see in the image here, the comparison from 100 meter to 20 meter to 5 meter accuracy is also dramatic, and Maxar prides ourselves in having highly accurate imagery. Next, I'd like to briefly cover our latency and the timeline from collection to decision making. For our customers that operate direct access facilities, the time from planning to delivery of intelligence can be under an hour. This is very important when every minute matters. Finally, let's talk about the depth of spectral data that Maxar is capable of collecting. This depth allows details that would otherwise be hidden to be revealed. By using various band combinations, where 8-band visible and near infrared band or additional 8 shortwave infrared bands, Maxar provides intelligence beyond what the naked eye can see. And all these pieces together make Maxar a valuable mission partner for governments around the globe. All of these features of Maxar imagery and intelligence support a variety of missions and use cases. As you can see here, these include preparation in situations such as order of battle, mapping, disaster, force protection exercises, and many others, or whether that be prevention in things such as crimes against humanity, insurgency, or terrorism, enforcement of border security, treaty verification, criminal activity, and maritime domain awareness, monitoring critical infrastructure and military activity. As we move through to countering, such as counterterrorism activities, narcotics, and many other use cases, assess damage situations, whether that be to critical infrastructure or military strength. And finally, respond to humanitarian and disaster responses. All of these are situations that Maxar is proud to be able to support our global partners, and we will walk through some of these. First, we'll look at monitoring and looking at border security. This is an example of a border between Indonesia and Malaysia. We're looking at an image from 2017 collected from the Maxar GeoEye-1 satellite. Through the use of our satellite imagery, you can monitor activity taking place at border facilities and see ongoing activity, as we see here at the Indonesian border post and the Malaysian border post. Next, we're going to look at disaster response. The first is an earthquake that took place, an earthquake and a tsunami that took place in Indonesia in September of 2018. This was a tragic event that killed more than 400 people and injured and impacted many others. Within days of the event, Maxar was able to assist in the response to this natural disaster. And during other natural disasters that happen globally, we collect images either the next day or very rapidly after the event takes place, and then are able to share that data through our open data program, where we share it with response teams on the ground. By collecting this timely, high-resolution imagery, damage can be assessed and responses coordinated. Knowing and assessing the damage in a situation like this, where a bridge is damaged and other infrastructure may be damaged, can save lives and save time. This is another image from the same day, October 2018, comparing the same location in August of the same year of 2018, collected from our GeoEye-1 and WorldView 2 satellites. So because of Maxar's deep archive, we can analyze change by comparing recent imagery with brand new imagery. And in this image, not only can you see extensive building and infrastructure damage, but you can see the extensive coastline changes. So not only can Maxar provide timely, high-resolution imagery, but we can also provide data layers that pinpoint changes. As we look here, we can classify those changes depending on the specific event. In this case, we classified vectors such as destroyed, damaged, or possibly damaged areas, so that then first responders could take this information and plan their assessment and plan their response. This is a similar example where we classified partially damaged, destroyed, or no damage building polygons with our building footprints derived product. These polygon layers can then be used in conjunction with our high resolution imagery to support disaster response teams. The final response that we'll look at today is a landslide and mudflow in Sierra Leone. And you can see images here comparing March 2017, before the event, taken from our WorldView 3 imagery, and August of the same year, taken from our GeoEye-1 satellite. You can see the extensive damage and the mudflow that took place. And we were able, again, to provide data such as this to our open data program, where responders can use this for real action on the ground. In addition to responding to natural disasters and other events, Maxar also supports our mission partners in prevention. We see here an image from our WorldView 3 satellite taken last fall in October of 2021. This is an example of new garrison construction in Russia. And this example can be also applied to many different situations around the globe. And we'll step through this specific image, which this slide shows an overview of this construction. But then as we zoom in, you can specifically see construction materials stored throughout the site and possible future shelters that are being built. Or again, because of our deep archive, you can analyze the change that is taking place at this construction site. So you can see in the older image on the right from October 2020, just early signs of construction taking place. And then as we move through in time to July of 2021, you can see additional construction that's taking place. And this type of intelligence can help in prevention by increasing transparency throughout the world. Additionally, we assess other activities going on globally. Next, we'll look at an enrichment facility in Iran from imagery collected in January of 2021. As we orient ourselves in this image taken by the WorldView 3 satellite, we can see pointed out the enrichment facility, a building that was destroyed in July 2020 from sabotage. And we can highlight other things that we'll walk through in this example, such as tunneling activity, construction camp, and multiple spoil piles. So if we zoom in on that image, you can see new tunnels being built through excavation, and you can see construction camps and storage facilities and spoil piles. And if we zoom in yet again, you can see the actual tunnel entrances plus the dump trucks that are actively working. Notice that one dump truck is empty and returning to the tunnel, and another is full at the spoil pile. You can also even see probable high explosive storage areas. All of this is possible to see because of our high resolution imagery. Here again, you can see how close we can get to that dump truck and again, verify that it is full at the spoil pile. Again, I just want to emphasize that this application can be used throughout the world and again, increases global transparency. And here's another overview site, an overview image of the same site. The next example that we'll look at is activity in North Korea, comparing an image in 2021 with our GeoEye-1 satellite. So we're looking at a nuclear complex in North Korea, and through this image, you can observe smoke at a coal-fired thermal plant, which provides heat to the radiochemical lab. As you can see in this slide, there are many other things that you can observe that we will go through. First, you can see, again, the coal-fired thermal plant. You can see activity going on around there, such as the conveyors and the crushers, where the coal is delivered from by rail to a covered shed, and smoke. You can even see and verify smoke from the stack. Here you can see probable production facilities, probable enrichment plants. All of these are, again, important to make imagery accessible to our partners around the globe so that they can monitor and analyze these situations. Lastly, for this site, you can see the experimental light water reactor. Next, I would like to switch gears from optical imagery from some of the other derivatives that Maxar has to support missions that we've been discussing. One of these is the globe in 3D. By using our extensive archive, Maxar is building the highest resolution, most accurate 3D map of the globe. The highlights of this globe in 3D include that it's based on commercial imagery, therefore it's unclassified, shareable, and able to be used throughout agencies. It has the exceptional geolocational accuracy with 3 meters SE90, which is generated without using GCPs. It's high resolution of 50 centimeters, and we have consistent global coverage. All of this leading to use cases both for commercial, but also for our government, defense, and intelligence users. To build this globe in 3D, we have to use the following: both our imagery of global coverage that's consistent from multiple commercial satellites, as automatic processing, therefore it's scalable. It is a unique technology that, again, has no need for ground control points, and it generates a true photorealistic texture on all sides of buildings and terrain features. And additionally, we have automated derivative products that are generated, and we'll walk through some of those as well. These products include our digital terrain model, our digital surface model, our 3D surface model, 3D vectors, and a true ortho. This 3D data supports our customers in planning and operations. And high-resolution surface models are ideal for line-of-sight use cases and viewshed calculations. Additionally, the precision 3D data can help with theater evaluation at scale, meaning because of its global coverage, it is available for large areas for theater evaluation, but it can also be, because of its high resolution, be used for smaller subsets and support accurate missions, again, without using any GCPs. Our true ortho provides visibility into inaccessible or dense urban areas. In this situation, for military mapping, you can get mission assurance from the clarity provided from our bird's eye view true ortho, which pulls every upward facing pixel so the imagery is at nadir and looking straight down, which improves visibility for planning. Or if you're doing route planning, you can have high fidelity for mission success. Precision 3D compared with alternative sources shows that it is highly accurate and an invaluable resource for different types of mission planning. As we can see here, this 35-meter high wall is not visible in traditional low-resolution data sets, but it is visible in the Maxar 3D surface model. Last, I'd like to emphasize again that this data set is unclassified and shareable throughout different organizations. Often, government organizations buy one high-quality data set for different missions, whether that be telco planning, line of sight, and others. But instead of buying different data sets for each of these use cases, Precision 3D can fulfill all of these requirements, saving customers, again, time and money. In conclusion, I'd like to say that Maxar is honored, and I am personally proud to be able to support all of these various uses of our imagery and data. Manny, I'd like to turn it back to you. Thank you.
Thank you, Rosalyn. That was such a wonderful presentation. I am singularly impressed by the resolution, the speed, the accuracy, and the impact that you're making with some of the intelligence that you're providing into the various sectors that you've discussed, from military and telco to disaster response and humanitarian planning. I'd like to ask you a couple of questions, if I may. In your opinion, what is one of the biggest changes you've seen in the IDI space over the past 5 years, let's say?
Great. That's a great question, Manny. Thank you for asking. I would say, as I touched on a little bit in the presentation, the increased transparency and the lower barriers to entry for different customers because of both cloud processing and the accessibility of internet connectivity and all sorts of other technology advancements. This imagery is accessible both at a rapid time scale, but also at a lower cost, and less technical capabilities are needed to access this type of data.
Great. Okay. And do many of Maxar's products make use of cloud?
Yes, a lot of ours do. You know, if we think back to years ago, I think in 2013, Maxar had all of our archives stored on hardware, and we had to replace the hardware for that every 9 months because of the rapidly changing environment and how much data we had. So really at that time, we had no choice but to move to the cloud. And it wasn't necessarily redundant. It was stored in 2 locations. But now that we're in the cloud, you know, the computing potential on that imagery and data is exponential. And in addition, we have products that allows customers to utilize the cloud. So we have a virtual ground station that operates in the cloud called our Rapid Access Program, that customers can access our satellites and plan their missions, all enabled because of cloud technologies.
That's brilliant. Okay, let's see how we can move from assimilating all the information that you shared with us to looking at specific civil government use cases. For that, I'd like to introduce Suki. Suki, I'll hand it over to you to give us a little bit of an overview of all the government use cases that you're supporting today in Asia Pacific and the globe.
Thank you, Mani, for the introduction. So Rosalyn has given a very thorough overview of how Maxar support the government missions in the defense and intelligence segment. Now, I would like to add more color on the civil government side, talking about some of the most common use cases that we see among the public sector customers in Asia Pacific, which includes maritime security, smart cities, natural resources, land administration, and infrastructure. I will elaborate on each of these in the coming slides. So first, let's look at natural resources. When we talk about natural resources, we are referring to primarily the forests, the water bodies, and mines. Typically, customers in this segment would like to create maps to track inventories and detect changes in these natural resources. And these usually cover a large area. So satellite imagery provide a very efficient way to map out these areas very quickly and keep them updated from time to time. And oil palm is a very important commodity in Southeast Asia because Indonesia and Malaysia account for about 90% of the total production for the whole world. And because of the specific way the oil palm trees are planted, the plantation operators and government agencies could use satellite imagery to detect and count the palm trees so that they can more accurately track the production output and assess the health of the plants. So satellite imagery serves as a very effective way to monitor oil palm plantation to ensure sustainability. Again, as you can see from the slide here, the oil palm plantation areas can be easily differentiated from the natural forest. And on the right side, this is how a new plantation area will look in the satellite imagery. These are all taken on the Maxar sensors, different years. Another popular use case among the public sector customers is land administration, where land agencies utilize satellite imagery to create and maintain digital records of land ownerships and boundaries. Traditionally, ground survey methods are being used to demarcate the land parcel boundaries. But with technology advancement, now we are moving the sensors higher into the sky by flying the planes at 30,000 feet, which is about 10 kilometers, or drones at about 300 to 400 feet. Now, we can even achieve similar accuracy level by using satellite imagery, which are captured 700 kilometers away from the Earth, which is really amazing. And smart cities is another interesting use case that can be supported by satellite imagery. One of the applications is for city planners to be able to create and maintain an accurate 3D model of the city for planning, design, maintenance, and governance. In addition, satellite imagery could be used to detect, for example, the amount of solar panels installed on rooftops for renewable energy, to assess air or noise pollution based on the traffic condition on the road. The high-definition maps produced using satellite imagery could be used for navigation in autonomous driving. So these are some of the applications used for the smart cities. And more recently, people have been talking about creating the digital twin, and this definitely applies to smart cities as well. Remote sensing and satellite imagery are contributing in a significant way to the new generation of digital twins by providing observations and measurements that being kept up to date to represent the real world. Next, for infrastructure sector, we have transportation agencies who want to create the plan, and when they construct the new roads, railways, waterways, and dams, they could make use of satellite imagery to create the land use, land cover maps, to create the digital elevation models that Rosalyn talked about just now, as well as the map that capture the transportation network in both 2-dimension and 3-dimensional space. So just look at some of the examples. This is an example in Indonesia. So the customer is using a couple of products such as the base map, the digital elevation model, and land use land cover map to assist in the route location and highway alignment. So the satellite imagery can be used throughout the entire life cycle for this highway planning and design. So this is called the Cisumdawu Highway. So as you can see from the image here, we are looking at different features, and they were looking at surrounding the location of the highway. And then over here as well, you know, there are some buildings that are blocking the right of way. And another image that was taken to monitor the situation on ground, showing that the building has been removed. And another image taken. So as you can see, over time, we can make use of satellite imagery captured at different time scale to monitor the situation on ground as the construction is going on. This is the most recent image. Yeah, and that's just a news clip showing the photo of the highway. Next, I would like to talk about the use case for maritime and IUU fishing, which stands for illegal, unreported, and unregulated fishing. So this is a very interesting use case where, you know, in the vast open oceans, satellite can capture like a few 100,000 square kilometers in one single image. And by correlating against the automatic identification system, we call it the AIS, broadcast by the ships, we can detect dark vessels who decide to turn off the AIS as they are seen in the ocean. So when we combine the high resolution optical satellite imagery, we are able to bring it to the next level by providing more granularity and context within few hours, within 2 to 3 hours. Once we detect some dark vessel, we can task the optical satellite to capture another image, which allows us to see a lot more details. So for example, we can identify transshipment activity, right? Another example, the detail allows us to identify the specific types of ship fishing activity. And because of the agile satellite taken at a very high degree of nadir, we're able to see the site of the vessel. You know, in this image, we're able to see the name of the ship, Costco Shipping. And for this one, you know, we can detect the type of vessel, and even with slightly different deck structures. So we're able to see, okay, it's the same type of vessel, but it's actually a different vessel. So all these are really possible with a very high resolution that Maxar imagery offers. So with that, I hope I have shown you enough different flavors of how satellite imagery can be used in different scenarios for the civil government use cases to support their missions. Thank you.
Thanks, Suki. That was really interesting. So I love that your use cases cover everything from protecting the ocean, maritime safety, digital twins, contributing to the economic development of a nation. There's so much happening. Why do you think the interest from imaging to intelligence or the interest in geospatial data is so much higher these days?
Right. Thanks, Mani, for the question. I think Rosalyn touched a little bit about that on the transparency and the various technology advancement. On the other aspects, I believe there are other factors as well, including the fact that a lot of countries, they started building and launching their own national satellites. So there's a lot more data that's available out there. That's one factor. And then another one, in the commercial space, there's also a lot more venture capitalist companies who have generated keen interest in investing in the space sector. So there's a lot more fund that's available to support the investment, the R&D activities, and innovation within the space. So with that, I think a lot of companies are able to generate different solutions and also create different demands in different applications.
That's brilliant. Thanks, Suki. Well, that was a fascinating 2 sets of slides. I think we're moving into the panel discussion portion.
Yeah, if I may, Manny, may I ask you a question?
Of course.
Great. I'm curious if government users want to scale their operations and introduce efficiencies in some of the use cases that we presented. How do you see cloud computing helping with that?
Great. It's right up my alley. So you've just both beautifully shown how space data and technology are tackling complex issues on Earth and transforming lives, whether it's from protecting the environment or to military intelligence that's safeguarding nations. Organizations are using space data in such innovative ways and redefining really how we research, make decisions, and see our world. You've also managed to tell us how much data we're collecting from all of these amazing satellites that are orbiting around the Earth. In fact, according to one of our own customers, Descartes Labs, satellite data collection will grow from 3 million square kilometers a day to 3 billion over the next 5 years. And we're already reaching a point, and you mentioned this, Rosalyn, much earlier, when you move from on-prem hardware to cloud, we're already reaching a point where it's impossible to store, analyze, and make sense of such massive amounts of data without cloud computing. Now, cloud computing plays a critical role in this. The most effective way to gain really rapid insights, to get answers, to make decisions from space is with advanced cloud technologies like artificial intelligence, like machine learning. And cloud companies like AWS have a role, a vital role in playing a supporting act to reducing the cost of innovation. I mean, a lot of what I do is literally helping partners and customers store, analyze, and process huge amounts of data quickly and efficiently. Now, I want to make this very specific. Maxar and AWS have worked together for years on several innovative projects that have advanced the use of both cloud storage and computing in Earth intelligence. As an example, specifically between Maxar and AWS, of how we innovate for our customers, we developed something called the AWS Snowmobile. So to solve pressing need for data transfer and storage, and Maxar Technologies became a very early user of AWS Snowmobile, which is an exabyte scale data transfer service that customers use to move extremely large amounts of geospatial data into the cloud. Maxar was also one of the early beta testers for Amazon SageMaker. That's our machine learning tool set. We typically use that for optimizing data storage, extracting insights from really high resolution satellite imagery. And so based on listening to our customers' need to access their satellite data, and at low cost, we also developed something called the AWS Ground Station, which enables customers to downlink data and provide satellite commands across multiple regions quickly, easily, and cost effectively without having to worry about building or managing their own ground station infrastructure. Pay only for the satellite time that they use. And again, Maxar was one of our first partners to demonstrate the transfer of satellite image from collection in space all the way through to using our ground station, all the way through to intelligence in just under a minute. So we've gone from weeks and hours now to minutes, which, as you said earlier, speed matters when there's life and death decisions in some cases to be made. So I hope that sort of gives you a flavor of how cloud and why cloud.
Yes, I think that's so interesting, and it makes me very excited about the future of Maxar and Amazon working together more. So thank you for that. I do have another question, and I'm curious what you're hearing from some of your customers of what challenges you might face in getting government specifically to adopt cloud technologies.
So cloud computing is gaining popularity in the technology sector, and governments can still occasionally be skeptical about adopting it. But government adoption of cloud and AWS cloud is increasing over time. This is because they can see the increase reliability, the scalability, and the sophistication of the cloud services. So things like security, governance, data security, training and educating the workforce, the culture change that comes with us. Those are some of the sort of areas that we invest in, that can be blockers that we invest in to try and make the digitization, the digital transformation, the move to cloud much easier. So let me tackle a couple of different ones to go into a little bit of detail. If we take security, for instance, we know that customers need to access and share data securely on a global scale. So AWS enables its government and commercial customers to share data seamlessly across multiple levels of security and certification levels. AWS has been architected, our cloud platform has been architected to be the most flexible and secure cloud computing environment available today. And our core infrastructure is built to satisfy the security requirements for the military, defense establishments, banking, and other high sensitivity organizations. This is backed by a deep set of cloud security tools. So we have over 280 security compliance and governance services and key features that sort of allow for all of this to happen. The second thing is training, enablement, cloud fluency. So organizations need individuals with cloud skills to help transform their business. We want to make it easy for people to have access to the skills they need to grow their careers, but also progress the mission goals of the institutions or the organizations that they're in. So what we're doing to enable that is AWS has invested hundreds of millions of dollars to provide free computing, cloud computing skills. In fact, we've made a commitment to train up to 29 million people by 2025 from all around the world. And these programs are specifically focused on public sector customers, reaching folks from all walks of life and all levels of knowledge in more than 200 countries and territories. So on this particular mission, AWS has already helped over 6 million people gain cloud skills. And the latest efforts build on the existing commitment by putting more skills, training, enablement into the hands of what we call builders, folks who are actually actively involved in growing these systems, managing these systems, outputting the intelligence that's making such a huge impact to so many different sectors, as we've seen through the course of both presentations.
That's awesome. Thank you for sharing that. I think that's really interesting, and again, very exciting to hear about what AWS is specifically doing to enable some of you, our customers, to move forward and use more cloud technologies. Thank you.
Great. Well, if you have more questions, I believe you can join Rosalyn and Sook shortly. But for now, we wish to thank you for the time that you've taken to listen to our presentations. And please feel free to reach out if you have questions. Take care.